is our group members, Nivita Sokalingam, Nur Husna Jurani, Siti Hazira Zakaria, Tanusha Sivakumar, and Nur Adila binti Hasrai.
Hi and Assalamualaikum to Dr. Nora. My name is Tazra binti Zakaria. So for today I will explain about project 1. This is about air pollution API index. So for the introductions, these days people are very worried about our air pollution. There are many resources of air pollution that including the emissions from the sea surface, forest and soil dust. Most of the times, these are the type of sources that already add the high level of air pollution that found in environmental and natural. There are many potentials that human made of the air pollution that very high concentrations in the environment, including the emission of automobile, factory, as well as combustion of biomass. According to a recommended Malaysia Air Quality Guideline, a pollutant concentration that of 100 on Malaysia Air Pollutant Index (API) is considered as a safe level. When API is above 100, it's considered as unhealthy that human to be outside in the air. As you can see here, this is the color of a Malaysian Air Quality Index. When the API 0 to 50 is a good level, when 51 to 100 is a moderate, when 101 to 200 is a very unhealthy air pollution, when 101 to 300 is a very unhealthy, and 101 to 50 is a very hazardous air quality index. Next is a comparison of location that we have been choosing is at Putrajaya, Wilayah Persekutuan Kuala Lumpur, between Malaysia Air Quality Index. In this session, we conduct a comparison between Air Quality Index of Putrajaya, Wilayah Persekutuan Kuala Lumpur, based on the standard Malaysia Air Quality. As you can see from the result, the results are shown for 2019. According to the index, we are able to see that the month of the June has the lowest API value, which is 54. That indicates that the value of health concerns in Malaysia Air Quality that can be classified as a moderate. In addition, the API value in March is the highest from any other months, that coming in at 68. This is because every year in March for Indonesia, Sumatra and Kalimantan, they indicates that smoke from fire that contribute the abnormally high level that we seen in March. This is because a high level of air pollution also can be experienced to our neighboring countries like our countries Malaysia, Brunei and Singapore, due to the wind transporting this thing that's a holiday smoke there. That's why when every year in March we have a very high API value index.
Assalamualaikum. My name is Nur Husna Jurani and my metric number is AN200043. I will present our project 2 regarding weather forecast in Malaysia. The data for the project was taken using the weather forecast link with the duration of 2 weeks from 1st January until 15th January 2023 at the location of Muar Town, Johor. Wind news represents information about the wind at a certain area during a predetermined period of time. Meteorologists use it to indicate the proportion of time that the wind blows in each direction throughout the observation period, velocities of these winds, and the frequency of calm air or light breezes. It is typically includes 8 radiating lines whose lengths are related to wind frequency. The thickness of the lines on them indicate the wind intensity, and the center of the graph displays the frequency of calm or almost calm air. The 8 points were identified by the initials of the major winds, with the east point occasionally varying across and the north point flow the least. It was linked with the magnetic compass and used as a compass card when navigation began to use it. Next is methodology. The data was taken using the weather forecast link with the duration of 2 weeks from 1st January until 15 January of 2023. It was taken 4 times a day and it is taken according to its wind speed and the wind direction in order to form a proper wind rules for the chosen area, which is Muar Town Johor. All the data were then gathered in an Excel sheet to differentiate each day's wind speed and direction.
Greetings, Doctor. I'm Niveta Sokalingam, and I'm going to be presenting about the procedure, data and analysis, and also the discussion part of the Windrose. So, to start up with the procedure of Windrose project, the project was given by Doctor, and we have chosen a specific place using the weather forecast link in order to construct a Windrose, and the place we have chosen is Muar, Johor. So each day the data was taken by screenshotting the weather forecast of each day. So the day we have started was 1st January and the day we ended is 15 January, which is about for 2 weeks we have taken the data using the weather forecast link. Then the data were inserted in a tabular form using Word and Excel in our report, and it was useful for us to construct a diagram using Microsoft Excel, and we have also done our summary using the windows that we have constructed. Moving on to the data and analysis part, this table shows the data of weather forecast according to wind speed and direction from 1st January 2023 until 15 January 2023. So we have clearly constructed a table from the data that we have obtained from using the weather forecast link. So we have mentioned in detail about the date, the time, the wind speed and the wind direction. So as we can see, the time is mentioned in 24-hour system, and for each day we have taken the data for 4 times, which is in the night, in the morning, in the afternoon and in the evening. So in the night the data was taken at 1 o'clock, and in the morning the data was taken at 7 a.m. in the morning, and in the afternoon the data was taken at 1 o'clock, and last but not least the data was taken in the evening at 7 o'clock from the very beginning until the end of 15th January. So these are all the data that we have obtained from 4th January to 7th January. As we can see, in the 4th January, the direction of the wind is northeast and northern. The direction of 5th until 7th is mostly, as we can see, it is siding on the northern direction, northern and western direction. From the data based on 8th to 11th January, we can see that the direction of the wind is mostly same as it is mostly siding to the northwest, northeast, and based on the data we have obtained from 12th to 14th January, the wind direction is mostly siding to the northeast and northern. And the wind speed is actually from 7 to 11, 11 to 14, and last but not least, we can see that the wind direction on the 15th January is mostly siding northern and northeast. So that's all for the data and analysis part. So here's the most important part of the Windrose project. This is our Windrose diagram. So this Windrose diagram shows the occurrence of winds at Muar, Johor, which indicates the strength, direction and frequency of the wind at the chosen area. This is our Windrose chart. So it shows the average of 0 to 3 until the average wind speed of 21 to 24. So the actual average of the lowest average of our wind speed is 6, and the highest average of our wind speed is 22. Now we are going to discuss in detail about the analysis that we have gotten from the Windrose. The average highest speed of the wind recorded, as I mentioned earlier, was 22 km per hour, while the average of the lowest wind speed recorded is 16 km per hour. The wind direction in the chosen location Mua is mostly siding to the northern side, northeast and also west, based on the surveillance of weather forecast that we have done for 2 weeks. So this proves that the winds at Mua, Johor during the period of time blows more from the northern during the period of time. So the average wind speed for the first 2 weeks in January and percentage of time that the winds are calm and the hours of data on which it shows it is constructed. Moving on to the next part, examining the winds from the northern, the longest spoke, one can determine that approximately 25 of the time in the 2 weeks at Mua, the wind flows from the northern at speed between 6 to 18 km per hour, as how we have analysis the windrows diagram and the data. So we have calculated that the wind blows from the northern at speeds between 6 and 18 km per hour is 6% of the time. So this represents that 0.06, we have multiplied it with the hours from the day, the very beginning until the 15th January, which is each day we have 24 hours and we have times 15 by 24, we have gotten 360 hours, and we have gotten the value of 21.6, which is about approximately 22 hours. Typically have winds from the northwest, northern at these speeds at Mua from 1st January to 15th January 2023. So that's all from me, Doctor. Thank you so much.
Next is conclusion. By conducting this project, we were able to extract the data according to its wind direction and speed to construct and windrows diagram, as well as to analyze in detail of the windrows diagram constructed. Our group has successfully achieved the aim of the study, which is to establish the poly model nature data while comparing the relative strengths of different sets of directions. With the aid of windrows diagram, we learned the importance of both wind direction and wind speed, which is crucial factor in order to happen air pollution. Whereas wind direction is crucial for the movement and dispersion of air pollutants. So, keeping an eye on the wind direction is crucial to avoid the negative consequences of the air pollution. That's all for Project 2. Thank you.
Hi Doctor, I'm Darusha Sivakumar and my metric number is CN200202. And hereby I'm going to explain about Project 3, which involves Toxflame Online and Google Earth. So as we all know, one of the most harmful type of pollution is air pollution. So in order to monitor air pollution, we have to go through some kind of modeling system. Through the process of modeling, a system is developed to replicate a real-world scenario. Several factors affect how the pollutants released from these sources spread throughout the atmosphere. So we have to go through the meteorological conditions, which are wind velocity, wind direction, ambient temperature, atmospheric stability and mixing height. A software program which called as Toxflame is based on an analytical solution to the atmospheric dispersion equation for inert compounds with a density close to that air and potential to experience first-order chemical or physical decay. Toxflame can compute the ascent of pollutant plume due to mechanical or thermal momentum and mimic the discharge from a point source, such as stacks or pole fires that are assimilated to point sources. According to a vertical profile that is dependent on land factors such as the roughness length parameter and the atmospheric stability, Toxflame extrapolates the wind speed at the release height. So here I'm going to explain about the data and analysis. We use Toxflame software to study the effect of parameters to the concentration of pollutant dispersion. The parameters chosen are wind speed, wind direction, temperature, mixing height and Pascal-Gifford stability. We changed one parameter at one time while the others are fixed for each cases. So first of all, I'm going to explain about wind speed. So we choose example 1, which is summer situation, which involves class A wind speed 1.5 meter per second, mixing height 1000 meter for our study. We also choose 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5 and 5 meter per second values as wind speed parameters to change at one time while the other parameters remain the same. From the graph that we plotted, wind speed is inversely proportional to the average concentration of air pollutant concentration. This is because the pollutants cannot disperse in low speed calm winds. So the pollutants will be increasing in the atmosphere. So smoke is a result of harmful pollutants in stagnant air. On the other hand, contaminants will be transported quickly if the turbulent breezes or even moderate wind blows. Lower pollutant concentrations are observed in such circumstances. It has been long known that evident that wind speed has an impact on air quality. Low wind speed are believed to encourage the production of the smoke phenomenon in cities, while high wind speeds can help the air pollutants to disperse quickly. Secondly, I'm going to explain about wind direction. We choose the same example, and for the wind direction we choose north, northeast, east, southeast, south, southwest, west, northwest and north values for our wind direction parameter to change at one time while the other parameters remain the same. From the graph we plotted, with the shape that we obtain of the wind direction and average interval air pollutant concentration is stable oscillating curve. We can conclude that the wind direction doesn't affect the concentration of air pollutant. Even though the wind direction didn't affect the concentration of air pollutant, we can conclude that monitoring wind direction is essential. In order to evaluate air quality, wind direction are crucial. Even wind direction couldn't assist us with the concentration of air pollutant, but it can give a clearer overall picture of what's going on the atmosphere and assist in locating the pollution sources. Thank you, Doctor.
Assalamualaikum, my name is Nur Adila binti Asran. My metric number is N 2069. I will continue about temperature. We choose values as temperature parameters to change at one time while the other parameters remain the same. From the graph that we plot, when temperature increases, the average interval of air pollutant concentration remains the same. High temperatures have accelerate the chemical reaction that produce pollutant like ozone and secondary particulate matter, and air pollutant cause the atmosphere to trap more heat. Weather and air quality are fundamental linked. Sunshine, rain, air currents and temperature all have an immediate impact on air pollution. During the summer, long days of sunshine catalyze chemical reaction between pollutants, and higher wind speed can disperse areas of concentrate pollution. The movement of air and thus the movement of air pollution is affected by air temperature. Because the Earth's surface absorbs solar energy, air near the ground is warmer than air higher up in the troposphere. And then, for mixing height, we choose from 1000 meter until 5000 meter while the other parameters are same. From the graph that we plot, average interval of air pollutant concentration is inversely proportional to mixing height. As mixing height is increased, then average of interval decrease. This is because the observation of the atmospheric temperature profile determines this height. A parcel of air rising from the Earth's surface will rise at a constant rate. The parcel of air will continue to rise as long as it is warmer than the surrounding temperature. However, if it becomes colder than the ambient temperature, it will slow down and eventually stop. The extent or depth to which smoke will be dispersed by turbulence and diffusion is referred to as the mixing height. The mixing height forecast is given in feet above ground level. Then, for particle differed stability, the graph that we plot, we determine the stability using three types, which is values of wind speed, values of particle differed stability, and the average interval of air pollutant concentration. Stability classes are assigned to different meteorological conditions based on wind speed and solar insolation during the day and cloud cover at night. And lastly, for conclusion, from the data and analysis that had been carried out in the summer situation using TOX Flam software, we can provide a conclusion for the meteorological condition and parameters and air pollutant concentration. The interval of air pollutant concentration became the responding variable, and the parameters such as wind speed, wind direction, temperature, missing height, and particle deferred stability had been the manipulated variable in this study. And then from the study, we can summarize that wind speed has negative correlation with air pollutant concentration and dispersion, where when the wind speed increases, the air pollutant concentration decreases. On the other hand, we find out that wind direction has no effect on air pollutant concentration, whereas the combination of wind direction and wind speed parameter can help the researchers to know about the whereabouts of air pollution in details. In addition, temperature has no correlation with air pollutant concentration, where the graph indicates the air pollutant concentration remains the same when the temperature is increased. Moreover, the missing height negatively correlated with air pollutant concentration. This is because the graph shows that when the missing height increases, the air pollutant concentration will decrease. Furthermore, the particle deferred stability, which involves the wind speed, indicates when the wind speed increased, the air pollutant concentration was decreased. From the study, we can summarize that for the summer season, height, wind speed, and height missing height are the major influencing factors which can reduce the concentration of air pollutants, whereas wind direction and temperature doesn't affect the concentration of air pollutant much.
That's all from us. Thank you so much, Doctor.